Hello everyone, welcome to the Infotech. Today we will learn event loop, its component and architecture in the Node.js platform. Before starting this video, I want from you to please like, share and subscribe. As Node.js is a single threaded, but many people have doubt that it is a multi-threaded. Here I want to tell you that actually Node.js runs your JavaScript code in single thread, which means your code can do one task at a time. However, Node.js itself is multi-threaded and provides hidden threads through the libuv library, which handles I/O operations like reading files from a disk or network requests or any timer functions. So there are different components in event loop like call stack, event queue, microtask queue, and libuv. Call stack, all your JavaScript code executes in the call stack. And in event queue, there are 6 different phases like timers, pending callback, idle prepare, poll, check, close callback. All timers callback will be executed in the timers, and all pending callback, like any deferred in IO cycles, any deferred to the next iteration loop callbacks will be registered in pending callback and execute here. Idle prepare is internally used by the Node.js, and any IO callback will be registered in poll phase. Set immediate callback will be registered in check phase, and closing events callback will be registered in close callback. In microtask queue, process.nextTick function registers callback to nextTick queue, and promise resolve reject callback will be registered in promise queue. And coming to the libuv, which is written in C language. So whenever you JavaScript there is a blocking code, then it will send through the libuv and it execute using the system resources. So your main thread will not be blocked, and whenever that operation is complete in system like network calls or database query or any timers function, then that their callback will be registered in the related phases in event queue, and that callbacks will be execute accordingly in the call stack. And for an example of libuv, if a program is querying the database, the CPU sits idle until the query is processed, and the program stays at a halt, thereby causing wastage of system resources and also block the main thread. To prevent this situation, libuv is used in Node.js, which facilitates a non-blocking I/O. Okay. Whenever you bootstrap or start your Node.js application in the server, first it creates a global context here, and it registered all your function variable, properties, classes, everything in the global context, and it will be alive till your application is running. So whenever any request come to your server, and it registered that callback in poll phase, and that callback will be picked from the event loop and put it in call stack, and it will create another function execution context. So it executes the code line by line in synchronous way. If any blocking code is there, then that will be sent through the libuv using system resources. It executes and registered its callback in their related phases, and priority wise those callbacks will be executed again in the call stack in a main thread, and it send the response accordingly whenever complete all the code of that handler function. As you can see in this picture, there are 3 requests are coming in our server, and when 3 requests coming to our server, first it passes through the HTTP parser, and HTTP parser trigger an event and register their related callbacks in the poll phase, in a poll phase queue. Event loop immediately pick that callback and register put in call stack, and that handler function execute in the call stack line by line, and inside that callback if there is any blocking code, then that will be registered again in the event queue phases or microtask queue, on basis on that for which phases the callback will be registered there. And whenever the event call stack is empty, event loop picks one callback on priority basis and again put it in call stack and execute in this way. In this way it works. So yeah, this is the complete diagram how it works. As you can see in the image event loop, first it HTTP parser triggers an event, goes to the poll, event loop pick that call handler function and registered in the call stack, and again call stack, if any blocking code is there then send through the libuv and execute there, and that related callback will be registered in event queue or microtask queue. And in the blue line again that callback will be picked by the event loop, and with from the green line it again put in the call stack and execute. Now coming to the definitions of the two phases, microtask queue and macrotask queue. Microtask queue nextTick and promise resolve reject. The callback by nextTick is called after current operation regardless of the current phase. It means it doesn't care about the current phase. It executes before taking any action by the event loop. Whenever any using process.nextTick any callback is registered in nextTick queue, that time it wait for the current operation in the call stack to complete, it finish, and once it finish the nextTick callback will be picked by event loop and it put it in call stack and execute immediately. So as you can see that in many cases that callback registered by nextTick is always execute first. This is the reason why it execute first, because it only wait for the current operation to complete. It doesn't care about where the pointer of the event loop is currently in which phase. It doesn't care about that. So always it execute first because it wait for the current operation to complete in call stack. Then once the queue of the nextTick is finished, the event loop move to the promise resolve reject in microtask queue and execute one by one just after the nextTick. Now coming to the macrotask queue. Timers, the callback scheduled by set timeout or set interval timer functions are called in this phase. In pending callbacks, execute IO callbacks defer to the next loop iteration. If any callback IO callback will be deferred to the next loop iteration, those callback will be put in pending callback and execute there from the pending callback phase. Idle prepare, it is used internally by Node.js. Here nothing to do anything with from the developer. Now coming to the poll phase, that is main phase of event loop phases. The poll phase has two main functions: calculating how long it should block and poll for IO, then processing events in the poll queue. When the event loop enters the poll phase, it checks for the timer phase that any callback is registered there or not. One of the two things will happen. If the poll queue is not empty, the event loop will iterate through its queue of callbacks, executing them synchronously until either end queue has been exhausted or the system dependent hard limit is reached. Here system dependent hard limit is reached depend on your system, like depend on the resources of your system, like on server or your local machine. So it decides the hard limit number based on your system resources. So it is not fixed what is the hard limit. So whenever there are lots of callback queue in the poll phase, then if we execute the callbacks one by one and it reached the hard limit, then it will come out from the poll phase and check for the set immediate callbacks in check phase and execute that. So it gives chance to all the phases to execute on timely, because if it is stuck in poll phase, because there are a lot of queues, then other phases will not get chance to execute and the response will be delayed to the user. That's why there is a system dependent hard limit is set. And if the poll queue is empty, one of the two things will happen. If scripts have been scheduled by set immediate, the event loop will end the poll phase and continue to the check phase to execute those scheduled scripts. If scripts have not been scheduled by set immediate, the event loop will wait for callback to be added to the queue and then execute them immediately. Again, I want, in a simple words, I am explaining this poll phase. Whenever the whenever a event loop enters the poll phase, first it checks for the timers phase. If there is any callback registered, then execute that if registered, and if not registered, then execute the poll phase callbacks one by one till it completes. Once it completes, again it check the timer callbacks if registered, then execute those callbacks. If not registered, then again move to the set immediate check phase and execute their callbacks. Now there are two more phases, check phase and close callbacks. Set immediate callbacks are invoked here, and all closing events like socket.on and socket.destroy or any closing events that will be executed in the close callbacks phase. Here they are, all the definitions are here. I told you. I will also show you the practical of event loop, how executing it, in the next video of this playlist. So please be with this video and watch that practical video also to get the complete understanding and knowledge of event loop. If you like this video, please like, share and subscribe. Thank you so much.